Welcome to Lesson 5. In Lesson 5, we're going to now start going more to the what's called the number crunching side of the Pythagoras theorem. It's called symbolic. And we want you to finally discover a relationship between the side lengths of a right triangle. Now remember, right triangle has a 90-degree angle in it. What I would do normally, if this was a class, is I would have you do some exploration, but because you're at home, it probably won't work. So I'm going to do something quite a little bit different here. In Egypt, every year the Nile River floods, and the farmland in its all the farmland in its flood zone. So basically, it washes out all the fields. All right. I would put you in groups, and I would ask you to figure out how do you think they would make sure that every year after the flooding, that everybody got the exact same farm area acreage back each time, right? So this is what they would do. If you take a look, I've got 4 farms here on the Nile River. Now what they will do is they will find something that so they'll put something down as a border, and they'll make sure that it can't be moved. So they'll get a big rock or something that the Nile will not get rid of, and they'll put a mark there, and they'll put it there, okay? And what they'll do then is, rather than put another one here and here, what ends up happening is these things will change because they're so close to the river. These ones up on this end, because they're so far from the river, it'll actually stay there, okay? So they put it someplace where it's not going to move. And now what they've done is they've found out that if you take a rope and you tie 12 knots in it, equally spaced, all right, you will find that it'll look like this. Okay, count the rocks, the knots, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, one too many here. Okay, I got my dots here a little bit off. I'm just going to correct that here. Okay, so I need 1. Okay, count the dots, there's 12 now. Now, if you notice this forms a perfect right triangle. So what they would do is they would take this rope, and then they would get someone to stand right here, and they would take this rope right here. Whoops. Come on. I want to take and join this all together. And they'd bring it over, turn it around, and they'd take that rope and they'd put it on that big rock. Now look what happens. Perfect 90-degree angle. So then they would know that if they sighted straight down the rope, this guy here, he would get right there. You could also sight this way and sight this way. So guess what we've got? We've now got 2 of the corners of the farms. Now remember, these aren't huge farms like Alberta has. These are small farms. You could then take the rope to the next location, right, which would be over where the next thing is here. Come on, move on. And they rotate it and move it to this guy, and it would tell him, you know, where this farm is, going there, and what farm there is. Right? And they would basically be able to recreate the borders of all their farms. This was discovered in Egypt a long time ago, though I know that there are people who claim that the Aztecs, the Incas, and the Mayans, and the Chinese all did it too. It's actually not a very difficult thing, but it's kind of cool. So, basic terms. I want you to be able to do calculations. We're going to eventually get into formulas, and you have to be able to identify something on the triangle. And that something is this. You need to know the hypotenuse is the largest, longest side. That is critical. If you think this is the hypotenuse or this is the hypotenuse, every question you do will be wrong. The longest side, right here, take a look right there. That is the longest. Don't care how you spin it or whatever, it's not going to work being the same length as this one here. or this one here. It just doesn't do it. It's the longest side. We call that the hypotenuse. Now, what I would normally do here is I would take you to the classroom and I would tell you to cut out a triangle. Sorry, to draw a triangle on a grid. And make sure it's a right triangle. And then because these are squares and this is squares, and then I'd have you do the calculations for this one here using the triangles and the big square and small square to find the length of L there. But this is what you would have found out. If this area here was 9, and this was 16, and this was 25, that meant that this would be 3, this would be 4, and this would be 5. Okay? And then what you should have realized is that 9 plus 16 equals 25. So if I add up these two numbers, which are the legs, the squares on the legs, if you add them up, you can get the square of the hypotenuse. Now we know that this here, 3, is just the square root of 9. So you can find that just by doing the square root of 9. You could find this 4 by taking the square root of 16. You can find the 5 by taking the square root of 25. So once I know the 25, the 16, and the 9, I can find the 4, the 3, or the 5. So if I have any 2, I can find the third one. So here is a demonstration of what it looks like. If you take a look here, here is a perfectly, I guess I should restart this, young lady here. Okay, I'm going to put it back to normal. This lady is actually, young lady, is going to show you a demonstration of the Pythagoras theorem. There is one of the squares, here is the other square, and here is the big square. So think of this as being the same thing we had. There's my 3, there's my 4, there's my 5, this is 9, this is 16, and this is 25. Now, I told you that this and this have to equal that. Well, watch. This is what you should see. Look at that. This and this equals this. If you go back, this here can be split up equally between this square here and this square here. This is the theory of Pythagoras' theorem. Basically, that the square of this plus the square of this has to equal the square of that. Now, if I know this one and this one, I can take this, subtract that, and get the other one. Okay? I'm not going to spend a lot of time on this here. I'm going to get out of it, and we're going to go back to what we were doing. All right, so let's go to the next question. This one here, this lesson, I would have had you take and have everybody in the class give me their numbers, and you should have come up with the conclusions that you just saw in that video. That this here lesson, sorry, that this one here, the area here, plus this area equals this area. Oh, I guess I missed one here. Okay? That's what you should have found out. This plus this equals this. Now, when we do our triangles and you do your calculations and stuff, you're going to be out a little bit, so they won't be perfect. But the squares of the legs add up to the square of the hypotenuse. Simple as that. So, if you take a look at our triangle, here's my right triangle, here is my first square, here's my next square, and this is the other square here. This here square, and this here square has to equal that square. A squared plus b squared equals c squared. Here's your 90-degree here. This relationship is called Pythagorean's theorem. He discovered that the sum of the squares of the two legs always equals the square of the hypotenuse. So let's take a look at how we can use this to find square roots without having to do a lot of work with grids. The first thing you need to do is to find the squares of these two here. So this is leg 1, this is leg 2, L1, L2. So L1, leg 1, is equal to 7 times 7, which is equal to 49. Okay? L2, the second leg, is 3 times 3, so this is 9. So what is the sum of these two? Well, 49 plus 9 equals 58. Using your calculator, what is the square root of 58? Well, the square root of 58, I'm going to take it to just a couple of decimal places, is 7.62. Okay? Now remember what we saw in the video. If I spin this around, this here and this here will fill this box here, won't it? That's what we mean by adding them together and making the sum. If I take L1's area, put it in here, and L3's area, and put it, L2's area, and put it in there, I will get 58. So now this is 58, and it's a square. To find the side length of a square is the square root of 58, isn't it? And that is approximately 7.62. Does this make sense? The answer to that is yes. Okay, the sum of the squares, sum of the leg squares equals the hypotenuse square. Now I want you to think about this compared to what we did before when you had the grids and the triangles and the big square and the small square, and you had to do all those 5 steps. Okay? If you want to do all that, you could, but it's a lot of work. But take a look at this for a second. There is a way to make sure you haven't made a mistake. We know that this is 7. I'm taking erase a bunch of stuff here so it's a little easier for you to see what I'm going to do here. We know this is 7. We know this is 3, and this is 7.62. This is actually, from here to here, it's longer than 7. And since it's the longest side, it's correct. If you got a number less than 7, it would be wrong. Because this length here, we know is the hypotenuse. It's the longest side. So this number here has to be the biggest. If it's not, you've made a mistake. Okay? Now imagine if you used a compass. This is another way to look at it. Imagine you used a compass to swing this around. All right? You'll see that this is 0.62, isn't it? And that's 7. So it does make sense. Okay, so imagine if you used a compass to draw an arc from the top using the length of 7 as the radius. Should the length of the hypotenuse be longer or shorter? Well, we just told you, and you figured this out. It's got to be longer. Is our calculation close? Yes. All right. Let's do another example here. You'll notice I'm still working with the legs and find the hypotenuse. So, what are the squares of the sides? Well, our first thing you got to show me is that 6 squared, you can write it like that, is 36. You can show me that 12 squared, and use your calculator, is 144. Now, what is the sum? 6 squared is 36 plus 144. You take those two numbers, you add them up, and you should get 180. So, what is the square root of 180? Going back to the side length of that square, that is 13.42. Now, does this make sense? Is it larger than all the two legs? And 13 is larger than 12 and 6, so this makes sense. Okay? So, square one leg, square the second leg, add them up, square root it. A lot easier to do the numbers than drawing all those triangles. All right, now, what I'm going to do now is we're going to give you an example to do right here. All right, so here's your triangle. We'll do this. Here's a triangle, okay? And I'll just pick some arbitrary numbers here. Let's say that this is 6 centimeters and this is 12 centimeters. I'd like you to take and pause the recording and find me the side length of the hypotenuse. Let's see. Okay, first thing you need to do, 6 squared is 36 Did I just do this one a second ago? I think I just redid the example. Yeah. Okay, we got to change this. Sorry. I'm not going to redo the recording just for this silly mistake. All right, let's say this is 5 and this is 13. Now try it. Okay, so 5 squared is 25. 13 squared is 169. 25 plus 169, that's 169, 79, 89, 194. Okay, now grab your calculator. The square root of 194 is 13.93. I'm going to round it off. All right, so the square root of 194. All right, and I'm using centimeters, so this is the centimeters. How am I going to mark this? Here we go. Did you tell me that 5 squared is 25? Did you tell me 13 squared is 169? Did you do the sum? Did you take the square root? 1, 2, 3, 4 marks. If this was in a example for a word problem, then you would have to take and give me a sentence. Okay, so that's how you find the square root, sorry, to find the hypotenuse. Now, let's work with going the other way now. Now, if you remember the video, when she had everything in here, she turned it upside down, and then it went back into this one and this one. So we know that this is the sum of these two here put together. So if I want to find, say, this, all I have to do is take this square, take away the 16, and I will have 25 take away 16, and that's 9. Doesn't that look interesting? Okay? So when you're trying to find the leg, we're going to use subtraction. When we're trying to find the hypotenuse, we're going to use addition. So here we go. I've given you a big number there in decimals. You have a calculator. It's not going to be too difficult. So what is the square of the hypotenuse? Well, 12.52996409 squared. Take a look at that. Should give you 157. Now, if you have zeros there, just round it off. What's the square of the 6 there? Well, 6 squared is equal to 36. Now, because we're finding a leg, we subtract. So 157 take away 36 is equal to 121. Now, the square root of 121 is the length of the leg, and that is 11. So take a look at what we did here. Once I give you the big one, the biggest one here, you take and you subtract. Okay, now remember it's the squares. This squared subtract this squared equals 121 squared, which means this is 11. Okay, so when you find the hypotenuse, you add. When you find the leg, you subtract. All right, here we go here. Come on. Here's an example for you to try. So using the last one as an example, find the find the length of the leg. Pause the recording and do it, please. Okay, first thing you need to do is get your calculator out. What is the square root of 316? That is 99856. What is the square of 30? That is 900. Is that right? That doesn't look right. My notes might be wrong. 900. Okay, so now we take and subtract it. That doesn't look right. 99. I'm going to double check a number here, okay? Just give me a second. Well, that didn't work right. Not my calculator. I just put it away by accident. All right, I'm going to find out what the square of 316 is. So 316 times 316 equals 99856. I guess I'm right. And then, oh, I see a mistake. It wasn't 30, it was 300. My brain's not doing well. So here we go. So we have 90,000 and 99,856. Now you have to subtract them. So 9, 9, 8, 5, 6, take away 9. I should pay attention more to my notes and it wouldn't be so difficult. So now when you subtract those two, you're going to get 9,856. So there's your subtraction. So that means that this length right here is going to be the square root of 9856, which when you do it is 99.287 meters. I kept to the nearest thousands there. All right, so go back over this. It's not that difficult. I know I kind of messed up with the numbers there for a second, but square this, subtract, square root this. All right? All right, take a look at the next question. Pause the recording, and this time I'd like you to find the hypotenuse. All right, let's take a look at how it works here. What is the length of the hypotenuse? Well, let's take a look here. This is kind of weird because I've got square roots already. Normally I don't have square roots. So what is the square of the square root of 4? Well, I want you to take and square this. Well, the square root of 4 is 2, right? And 2 squared is 4. Kind of bizarre, isn't it? Square root of 20 is basically square root of 20 squared. So you have to take your calculator and put that in there, and that's actually 20. All right? Now, add the areas. 20 plus 4 is 24. What is the square root of 24? 4.9 meters. Now, this stuff is kind of tricky. So let's do a couple of extra examples. So, we know that 9 squared is 81. What is the square root of 9 squared? Well, since we know that 9 squared is 81, we're really asking you for the square root of 81. So, square root of 81 is 9. So take a look at it. If you want to find out what the square root of 9 squared is, remember this is 9 times 9. So what are you multiplying by yourself to get 9 squared or 81? It's 9. The second one would be, what is the square of, say, 5? All right. This is asking you to take 5, the square root of 5, and multiply it by itself. Well, any number multiplied by itself is the square, so that is 5. So take a look, play with your calculator, see how to do this, because you're going to have to reproduce this on a quiz. Okay, so we'll see you in the next lesson.